Hello, today we're going to be going over a couple of things. One, the distance formula, and the other is the midpoint formula. Now, these are two things that I expect that you've already seen at some point in one of your other math classes, but I think it's good to review it and good to kind of talk about where we get some of those formulas from. And, if you need more help beyond what I'm giving you today, just let me know. I've got additional examples, but because you've seen it before, I'm only going to go over a few. So let's take a look at probably the most basic distance formula question that you could have. Let's look over at something like this. Let's find the distance between 2, -3 and 5, -3. So this one right here is something that we can just actually count the blocks because we're just counting over units here. So we're going to go 1, 2, 3, and that's our distance. So the distance equals 3. Now, you might ask yourself, well, how can I do that if it's at an angle? Like our next example is going to look like this right here. Notice on this one, we cannot count because we're not actually, it's going over 1, 2, I don't know if you can see it or not on this, and if I held it up, it probably would be too blurry, but this isn't a full block right here, but it crosses through. So when it's at an angle, you can't just count, but if it's parallel to the x-axis or the y-axis, you can just count it over. Here's where we're going to say, all right, notice that, excuse me, notice that our y-coordinate here does not change, only our x-coordinate does, and you could say that this is 5 minus 2, and that gives me 3. And that's key to understanding that distance formula. If you remember it from a previous class, the distance formula is that long formula that we're going to look at in a second, but this is where the whole idea for it comes from. In fact, when I teach geometry, one of the things I hand students is a ruler that's been broken. Now, this one is not broken, but pretend like it is. Pretend like this section over here is broken off. We could actually measure this line right here by saying the end point minus the beginning point. So right here, it's beginning at 5. I know you can't see it because of the glare, but it's beginning at 5 and it ends at 5 3/4. So if I did 5 3/4 minus 5, I'd get 3/4 of an inch. So if we're talking about in inches, it's about 3/4 of an inch long. And so it's that end point. In this case, when I'm looking on an XY grid, I'm saying the end X point, which is 5, minus the beginning, which is 2, and I get 3. I know it's a long explanation when you just say, hey, all you're doing here is you're just counting this stuff out. Well, yeah, we're counting it out, but this is going to get built to more complicated math that we do later on. So that's why I'm kind of giving you that longer explanation for such a simple topic. So endpoint minus beginning is what we're starting to look at here. So now let's take a look at something that isn't exactly parallel to the x or y axis. In this case, we're going from -5, -3 to 4, 3 right here. And here's where we can use the distance formula if we want to. So if we write out the distance formula, let's go through some of these examples here. If we write out the distance formula, it was distance is equal to the square root of y2 minus y1 plus x2 minus x1, and these are squared. So this is our distance formula right here. Notice it's a lot, and we've got the 2 points, -5, -3, and 4, 3. So -5, -3, and 4, 3 are our points. Whenever you do something like this, whether it be distance formula, whether it be midpoint, or whether it be slope, make sure that you label your x's and your y's here. So I'm going to call this x1, y1, and this one x2, y2. And I'm going to substitute those into the formula. So my y2 is 3, and my y1 is -3. And then the x2 is 4, the x1 is -5. Make sure you put that minus a negative in there. So this becomes 6, and this becomes 9. And don't forget you're square rooting all of those. 6 squared is 36, and 9 squared is 81. So you're adding these up, we get 117. And so the square root of 117 becomes our distance there. So we can't break this down any further. We're just going to leave it like that. If we want to get an approximation, though, we can look at our calculator here and say, what is the square root of 117? So second square root 117, we get about 10.8. So just to check this, let's look at what 10.8 looks like. I got my old piece of paper here. I'm just using this as kind of like a ruler. I'm going to take and just measure it like this. We go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it's really close to 11. It's going to be somewhere right around in there. And if we look at it, we had 10.8, which is pretty close to 11 as well. All right, so that's one way to figure out the distance between 2 points, is using that distance formula. The other way has to do with making a triangle here. So if we make a triangle, and it doesn't matter if I make the triangle below or above this line. I could make it above it like this. But this needs to be a right triangle, and thankfully all these gridded points are perpendicular to one another, the gridded lines. Now, how can we use, or what can we use to figure out the distance of this side right here? I'll give you a hint. That side is the hypotenuse in that right triangle. So you think about that. All right. So hopefully you had a chance to look at this and think, wait a minute, I remember a thing called the Pythagorean Theorem. And the Pythagorean Theorem says this: if we have a right triangle, and one side, call it A, the other side called B, and then the hypotenuse, we'll call it C, then A squared plus B squared equals C squared. So we can use the Pythagorean Theorem here to help us out. So looking at this, we need to know this side. And remember, with it being parallel to the y-axis, we can just count to figure out that side. 1, 2, 3, 4, 5, 6. This side is 6 long. And this side, 1, 2, 3, 4, 5, 6, 7, 8, 9. This side is 9 long. And now I can put that into the Pythagorean Theorem and say, 6 squared plus 9 squared equals C squared. 6 squared is 36. 9 squared is 81. And so 117 equals C squared. Square root both sides. And you get the square root of 117 is equal to C. Wait a minute, that's the same thing we got over here. In fact, if we compare the two, notice we've got the same numbers working in here, okay? The only difference is they call this C, D for distance, and they already had both sides square rooted. So my next question is, in this distance formula, where are these two things coming from? Let's look back, and I want you to pay attention to this point right here. Let's write down the ordered pair for that. This is at 1, 2, 3, 4, 1, 2, 3, 4, negative 3. So notice, if we're concerning ourselves with just this distance, suppose it was something that we can't just count. You know, here we've got it graphed and count, but if it gave you huge numbers like 52, 1017 and 36, negative 4, you wouldn't be able to graph it and just count the things out. But how could you still figure out this side of the triangle? Well, the y values are the same, but notice if we subtracted the x values, going back to that end point minus the beginning point, the end point 4 minus the beginning point negative 5 gives me 9, because 4 minus a negative 5 is the same thing as 4 plus 5, and I get 9 there. Same thing over here. Notice the y-coordinate, well, not the y-coordinate, but the x-coordinate is the same, but the y-coordinate is different. So if I take the end point minus the beginning, I get 3 minus the beginning, which is negative 3, and that equals 6. So that's how I come up with my sides. It goes back to that measuring the broken ruler. You take the end point minus the beginning. But how do we write this out for just any old 2 points, not just this specific triangle here. Well, notice that this point right here could be considered the same as the x2 value because it's the same as this point up here. And then I'm subtracting from it the beginning point, which is my x1 point. So I get x2 minus x1, and that gives me this side of the triangle. Likewise, this is y2 minus y1, and that gives me this side of the triangle. And so now when I look at this y2 minus y1 and this x2 minus x1 right here, those are just the sides of a right triangle. You're squaring them, adding them up, and taking the square root. You're doing the Pythagorean theorem whenever you do the distance formula. It's the exact same thing. It's just for some reason we want to make it all complicated and put it into a formula, which if you're good at memorizing formulas, it makes it easier. But most students I know are not too happy about just memorizing stuff. At least I hope you're not. I hope you're wanting to learn how this stuff works. So it's really just the Pythagorean theorem. In fact, when we talk about the equation of a circle, if you remember that from geometry, it's just the Pythagorean theorem or the distance formula as well. I'm not going to get too far into it, but if you look at our equation of a circle, here you have a circle and it's centered at HK, and then there's a point on the circle XY. And we get into conic sections, we'll talk about this more. This is the radius R. The radius is the distance between these 2 points. So that formula I had to memorize for geometry for equation of a circle. Actually, I think it's on the formula sheet on most of your tests, but it is the exact same thing as distance. And you can use it to solve distance. You can use it to solve Pythagorean theorem. So all these things are related because you are just talking about the distance between 2 points. Go ahead and try one more. Let's try finding the distance between the point 1, 2 and 4, 6. I'll let you go ahead and draw that out. You can pause the video if you want and try it out. And so if we look at it, I'm just going to sketch out a Cartesian plane here. 1, 2 is going to be about right here, and then 4, 6 will be over here somewhere. So here's 4, 6, here's 1, 2. So here's a case where I can't count out because I didn't actually draw graph lines. But remember, if I'm looking at this point right here, it should be the same y value 2 and the same x value 4 because it's directly below right there. So that's where that point is on that triangle. That makes the side of this triangle 4 minus 1, which is 3. And the side right here on this triangle, 6 minus 2, which is 4. And now I can do the Pythagorean theorem. I can say that 3 squared plus 4 squared equals your distance squared. So I get 9 plus 16 equals d squared, or 25 equals d squared. So the distance is equal to 5. All right. You might say, but Mr. Burnett, I really like knowing my formulas. I like to memorize the distance formula. I had it memorized already. I just want to plug it in and chug it away. That's fine. You know, I don't care if you use the distance formula. I know a lot of students, they love using Pythagorean theorem. You can use whatever works for you. I just wanted you to know that they're both available for you to use, okay? So let's take a look at another type of problem. Let's look at the midpoint formula. So here's our first question. Suppose I have these 2 points, 3, 8, and 5, 2. And I'm wanting to know what is the midpoint between those 2 spots. So what is the spot that is exactly halfway between the 2? You can look at this a couple of different ways. Some people like to draw out triangles on this one. Some people like to use the midpoint formula. Let me show you the midpoint formula in case you forgot it. So the midpoint formula says this. It says x1 plus x2 over 2, comma, y1 plus y2 over 2. And this is all wrapped in one big set of parentheses because it is an ordered pair that falls between here. So if you want to do that, once again, write out your points, 3, 8 and 5, 2. and label them. So you're going to label them x1, y1, and x2, y2, and then substitute them in the formula. So my x's are 3 and 5, so 3 plus 5 over 2. And my y's are 8 and 2, so 8 plus 2 over 2. So I get 8 over 2, comma, 10 over 2, which is 4, comma, 5. And if I see this here, let's check it graphically. 1, 2, 3, 4, up, 1, 2, 3, 4, 5. This point right here, and that does look like it's exactly halfway between those 2 points. So that's one way you can do it. You can do this graphically as well, although most of the time we don't, just so you can see a graphical representation. If I have a triangle going on right here, you kind of think of it as slope. If I come over 1, up 3, I land right here, then over 1, up 3, I land right there. So this is exactly halfway. Not a lot of people use a graphical method on that just because it's so much faster just to calculate it out. Now, you can do it that way. If you love doing formulas, go for it. I think there's an easier way and a way that's less confusing, because a lot of times as students start memorizing these formulas, they go, okay, I've got the distance formula, I've got the midpoint formula, I've got the formula for slope, and they all have these x1, y1s, x2, y2s, and sometimes you add them, sometimes you square them and square root them. And they all get jumbled up. They're easy on their own individually, but then people start jumbling them up. So here's what I would do for midpoint formula that keeps you from jumbling all that stuff up. Take your 2 points, so you've got 3, 8, and you've got 5, 2. Write them right above one another, okay? It doesn't matter which way you write it there, but write them right above one another, and we're going to add them. So just straight up add them. 8 plus 2 is 10. 3 plus 5 is 8. And don't forget to divide them by 2, okay? Because if you don't divide them by 2, where is 8, 10 on this graph? 8, 10 is way out here. It's not halfway between the 2 points in question. So divide them by 2. It's an important step. And you get 4, comma 5, which is our midpoint. Make sure you wrap it in parentheses because it is an ordered pair. It is a point on the graph. If you don't wrap them, I don't know what 4, comma 2 means. You know, I want to know that you know it is a point on the graph. So make sure that you wrap them in parentheses. So I know you're talking about a point. All right, try out this one. We want to find the midpoint between negative 318 and 4, negative 5. So try that one out. All right, once again, I don't care which way you do it. You can use the formula or you can just do my method. I'm gonna do my method and you can check if you did a different way, check to see if you got it right. So I take negative 318 and 4, negative 5. I'm going to add these up. So 18 plus a negative 5 is 13 and negative 3 plus 4 is 1. Now I gave you this one on purpose because for some reason, students don't like fractions, okay? It happens every year. They hate fractions. This year, you're gonna learn to love to work with fractions. I don't want decimal points. The only time I want decimal points is when I tell you I want decimals, and that won't be very often, okay? So leave them as fractions. It's okay if they're improper fractions. If the number's bigger on top, that's okay. Don't give me 0.5 and 6.5 here. We have to become comfortable with working with fractions because we're going to see them a ton. And as you get more comfortable with fractions, it's going to help you with your other math classes because we're going to use fractions a ton and when you get to calculus. So divide both of these by 2. And that's where we're going to leave it. 1/2 and 13/2. Okay? Fractions are okay. So throughout all that, I hope that you got a good refresher on midpoint and distance. We will use that some this year, so I want to make this video for you. Let me know if you have any questions or if you need additional examples, okay? Thanks for watching and keep working hard.